I'd like to invite up Dr. Charuta Furey to present the top pediatric abstract, Exome Sequencing Identifies Novel Molecular Determinants of Human Congenital Hydrocephalus.
Good morning. My name is Charuta Furey, and I'm a fourth-year medical student at Yale in the laboratory of Dr. Christopher Colley. Just want to thank y'all for your time and for this opportunity to present our research, which is centered on understanding the genetics of congenital hydrocephalus. Now, hydrocephalus, with an estimated prevalence of 1 in 1,000 births, is the most common disease treated by the pediatric neurosurgeon, and it exerts a tremendous burden on our healthcare system, consuming over $2 billion annually. Now, perhaps paradoxically, our treatments for hydrocephalus are primarily symptomatic, comprised largely of surgical shunts that are riddled with infectious as well as mechanical complications. Now, despite evidence for a genetic basis of the disease, our knowledge of specific hydrocephalus-causing mutations and their pathogenic mechanisms remains primitive. Now, to date, there are only 4 hydrocephalus-associated mutations identified in humans, and taken together, they fail to explain the vast majority of hydrocephalus cases. So in order to identify genetic drivers of congenital hydrocephalus, we recruited and exome sequenced a cohort of 447 individuals from all over the country, comprised of 130 patient-parent trios and 57 singleton patients. And so this is by far the first and largest exome sequencing study of non-syndromic hydrocephalus. We identified multiple de novo and transmitted mutations in 3 genes essential to neurodevelopment as well as ciliogenesis, including LET7T, an E3 ubiquitin ligase that's integral to neural stem cell pluripotency and programming, SWE/SNF, a chromatin-modifying complex important for telencephalon development, and PATCHED, a sonic hedgehog receptor that's essential for ciliogenesis as well as embryonic development of the neuraxis. So interestingly, relative to HES5 positive controls, you can see that each of these 3 genes is highly and specifically expressed in the subependymal and subventricular zone during murine development. So in order to further functionally validate these candidate mutations, we created CRISPR-Cas9 knockouts in live frogs. And so by using an albino species of Xenopus tropicalis, we're able to use QOCT, which is a form of ultrasound, in order to visualize their ventricular flow and ciliary function in real time. And so this is an incredibly interesting novel mechanism of candidate mutation screening that's incredibly affordable. It's about $35 per CRISPR, and it only takes about a week after sgRNA microinjection in order to see a phenotype. So here you can see that relative to controls, patched mutants clearly recapitulate our patient phenotype of congenital hydrocephalus and aqueductal stenosis. And what's really interesting is when these tadpoles are raised to about 2 months, they continue to demonstrate hydrocephalus. So in summary, this research first identifies 3 novel hydrocephalus-causing mutations that explain about 6% of non-syndromic hydrocephalus. Second, this establishes a high-throughput in vivo candidate mutation discovery platform for hydrocephalus that combines exome sequencing, CRISPR-Cas9 gene editing, as well as QOCT in order to create Xenopus models of our hydrocephalus patients for the purposes of disease modeling, target validation, and drug screening. And finally, this research supports a novel paradigm for certain subtypes of hydrocephalus as disorders of neurodevelopment, specifically aberrant ciliogenesis, as well as issues with neurodevelopmental transcription. So this research would not have been possible without the support and mentorship of my principal investigator, Dr. Christopher Colley, as well as the scientific guidance of Drs. Murat Ganel and Richard Lifton. I'd also like to thank the members of my laboratory, our collaborating and referring physicians, and most importantly, the members of the Hydrocephalus Association and families affected by hydrocephalus that participated in the study and make research to better understand this disorder exceptionally fulfilling. Thank you all for your time.